So now we're going to do a route information protocol lab, and I'm going to run RIP between router 201, router 1, and router 2. We're going to exclude router 3 and router 4 from this lab. So let's go to router 201. I've already erased those static routes that we had on these routers. If you check, there are no S's. Router 201 is only aware of its directly connected network. The reason I did that is because static routes have an administrative distance of 1. And as you will see shortly, route information protocol has an administrative distance of 120. So if our static routes were in place, for the router to make a forwarding decision, if 2 routes to the same destination are present in the routing table or on the router will install the one with the lower administrative distance in the routing table. So if our statics were still present, our route information protocol with an administrative distance of 120, which is higher than 1, would not work. So to start the routing process on the router, you say router, and then you pick your routing protocol. I executed the help feature, and for now, we're going to pick RIP. So router RIP for route information protocol, or routing information protocol. Then I'm going to do what is called a network statement. Now, the network statement defines a list or defines a range of addresses. If an IP within that range is present on the router, the interface on which that IP is sitting is included in the routing protocol. So sometimes you will hear people say that the network statement enables the router to send routing updates. No, that is a secondary function. Yes, the router will send routing updates or start sending routing updates. But the primary purpose of the network statement is that it defines a range of addresses. And if an address is present within that range on the router, then that interface on which that address is present is included in that routing protocol. So if I say network, and the only network present on router 201 is the 200 network, 200.200.200.0, then I'm defining a range. This is a class C address, 200, and the range is between .1 and .254. So the first valid address is 200, 200, 201, and the last valid address is 200.200.200.254. Now, do I have an address within that range present on the router? Yep, I do. So if I say do show IP interface brief, I see that IP address 200.200.200.2, which is within the range between .1 and .254, is present on serial 010. Hence, serial 010 is included in the routing protocol RIP. Now, as a secondary function, serial 010 will start sending routing updates. That is the only network that is present on router 201. I save my work, and I move on to router 1. Now, router 1 has 2 interfaces, the serial link and the fast Ethernet link. The serial link is the 200.200.200.0 network, and the fast Ethernet is the 150.101.45.0 network. So let's enable the routing protocol, router RIP, and then we will include the serial interface in our RIP process by saying network 200.200.200.0. And since, if I look at show IP interface brief, since network 200 exists on serial 000, serial 000 is included in RIP. Next, I'm going to do network 150.101. Network 150.101. I could type in network, or I could shorten it to net. It's all the same. Network 150.101. Now, remember I said that RIP is a class full routing protocol? Well, 150 falls within the class B range. 150 falls within the class B range. And the class B range has a /16 mask, or 255.255.0.0. Only the first 2 octets are part of the network, and the last 2 octets are reserved as host bits. So what I should type, since a default class B mask is /16, what I should type is 150.101.0.0. This is the correct way of doing it. What happens if I type 150.101.45.0? The router accepts it, but if I look at my show running config, and I look at RIP, I scroll down to RIP, look, the router fixed the command for me. It took away that 45 and just put 0 in its place. Now, do not try that on the test, please. You could have points taken away. I'm just showing you that if you make a mistake, the router fixes it for you. However, you should know that you have to type 150.101.0.0. Since it is a class full network statement, since RIP version 1 is class full, and subnet mask information is not sent in routing updates. So we're done with router 1, and I will save my work. Let's go to router 2 and include, I'm going to include show IP interface brief. I'm going to include fast Ethernet 00 in the RIP process, fast Ethernet 0, turn off debugging, fast Ethernet 0/1.10 in my RIP process, and fast Ethernet 0/1.20 in my RIP process. So I go to configure terminal, and then I turn on the RIP routing process by doing the command router RIP, and then I do a network statement for the 150 network to include the fast Ethernet 00 interface in RIP. And then I do a network statement for the 10 network. Now 10 and 20 are class A. And class A, the default mask is /8 or 255.0.0.0. So I'm only going to type in 10.0.0.0. And then for the network 20, 20.0.0.0.0. If I type in 20.20.20.0, the router will fix it for me, but I want to do it correctly on my own. We save our work, and let's go to router 201 to see if this actually worked. On router 201, if I say show IP route, you guys see these R's on the left-hand side? That stands for RIP. I could clean this output out by a little bit by saying show IP route RIP, or typing show IP route RIP, and then I only see RIP specific routes. It filters out the connected route that we saw previously. Now, it says that network 10.10.10/8 is available via 200.200.201, which is router 1 serial 000's interface address. So router 1 is the router that is sending us updates about network 10. Router 2 is sending updates to router 1, and router 1 is sending updates to router 201. Now, this 120, the first number, as I said previously, is always the administrative distance. And the default administrative distance for RIP is 2. The second number is the metric. So network 10 and network 20 are 2 hops away from router 201. And network 150 is 1 hop away. Is that true? Yes, it is. If you're sitting on router 201, network 10 and 20 are down here. So network 10 and 20 are 1 router hop, 2 router hops away. And network 150 is this guy over here between router 1, 2, 3, and 4. Network 150 is 1 router one router hop away, the hop being router 1. A few more commands to look at. What if I say show IP protocols? I see that I'm running RIP and I'm sending updates every 30 seconds, next one due in 9 seconds. The route invalid timer is 180 seconds. The hold down time is 180 seconds. And the route flush timer, Cisco sometimes also calls this the garbage collection timer. I don't know why they like to use fancy language. But the flush timer is 240 seconds, the timer after which the route is flushed if no updates are received from the routing table. Serial 010 is part of the RIP process, and it is sending version 1. So we are running RIP version 1. It can receive version 2 and 1, but since we are sending version 1, we are running version 1. Now, this counter at the bottom, last update was 9 seconds ago. Last update was 13 seconds ago. So, you never want to see this counter increment past 30 because the update timer is 30 seconds. So if you get an exam question where this update timer is all the way up to, let's say, 220, you check the flush time because it might not be default on the test. You do the command show IP protocols. So in this case, the flush time is 240, which is a default, but on the test, they might have changed that to something else. So in this case, if this update, the last update received was 220 seconds ago, and it gets flushed after 240, the answer, one of the answers would be this route is going to be flushed from the routing table after 20 seconds. Because 220 plus 20 is 240. Now, one more command to show you. Let's go to router RIP. Okay. The command is not part of packet tracer, but I will just type it out for you. You guys see that the maximum paths says 4? Well, this means if 4 paths are available between your source and destination, or between your router and some destination network, RIP version 1 can load balance across those links for up to 4 paths. So RIP version 1 will send equal amounts of traffic over all the links for up to 4 paths. So if 3 are present, it'll use 3. If 5 are present, it can't use all 5. It will use 4 of those. And when I say equal cost paths, I mean paths with equal metric or paths with equal hop count. The command available on a real Cisco router is maximum paths and then the number of paths. I believe you can increase that up to 16, but then again, that is platform dependent. It depends on how much money you spent on that router. Next command we're going to see is a debug command, and we're going to go to router 1 to see it. So I'm going to say debug IP RIP. I'm going to wait a little bit. I need some debugging to pop up on screen, and it did. And what I want to show you is router 1 is sending V1 or version 1 update to the destination address 255.255.255.255. So RIP version 1 sends its updates to the all host broadcast address. And it is sending updates through its serial 000 interface, which with the IP address 200.200.201 towards router 201. And these are the networks and the metrics that it's sending. So network 10 with the metric of 2, network 20 with the network of 2, a metric of 2, and network 150 with the metric of 1. That concludes RIP version 1. Now we're going to switch over to RIP version 2. So how do I switch over to RIP version 2? I go under the routing protocol or the router prompt, router RIP, and you see it says config router. That means this is the router prompt, or it's commonly known as the router prompt. So I enable RIP, and then I simply say version 2. So let me go ahead and do that on router 1 and router 2. So I'm going to go to router RIP and then version 2. Let's go get router 2 done. I'm going to say router RIP and then version 2. And at this moment, I am done configuring RIP version 2. Now, let's go look at our routing table again on router 201. Do show IP route RIP. Now, RIP version 2 is a classless routing protocol, which means subnet mask information is sent in the routing updates, which means I should not be seeing this default /8 mask for the 10 network. I should be seeing a /24 mask because that's what exists on router 2. And to prove it, I'll go to router 2 and show you the running config. Do show run or running config. And if you see, the 10 networks have a /24 mask. 10 and the 20 networks have a /24 mask, which is 255.255.255.0, not a /8 mask, which is 255.0.0.0. Well, the reason being, even though subnet mask information is being sent in the routing updates, RIP version 2 auto-summarizes network addresses to the classful boundary. So even though this should say 10.10.10.0/24, by default, RIP creates a summary meaning a bigger network that encompasses the smaller /24 network. This /8 network encompasses more addresses because there are 24 host bits. A /24 only has 8 host bits. So a /8 network is a bigger network with a bigger host range than the /24 network. RIP version 2 auto-summarizes to the classful boundary by default. However, we can turn off this behavior. So let's turn it off. We say no auto summary on router 201. And let's go get that done on router 1 and router 2. No auto summary on router 2 and router 1 actually, and then no auto summary. Go back into the routing process and say no auto summary on router 2. And now let's go check our routing table on router 201. Do show IP route RIP. Now what do we see? Well, what we see is you see the network /8 still in your routing table, but the 20.20.20/20.20.0/24 network is also there, and the 10.10.10.0/24 network is there. Same for the 150 network. The 150.101.00/16 network is there like it was previously, right here, before the no auto summary command was executed. But now the correct address is also here, which is the unsummarized address, the 150.101.45.0. Now I will show you why this happens in about a minute. Now, I waited a total of 180 seconds because now router 201 is getting updates for the 150.101.45.0/29 network, not for the 150.101.0.0/16 network. So after 180 seconds or 3 minutes pass by, now in the routing table it says this network is possibly down. Okay? The 10 and the 20 networks are for some reason still getting updates, but this should also soon say that these networks are possibly down. The 20 network now says this network is possibly down, and the 10 network says this network is possibly down, because updates for the 10.0.0.0/8 network have stopped, and updates for the 10.10.10.0 networks are coming through. So after 180 seconds, which is the route invalid timer, as I said before, this network, the previous ones, the /8, the /8 and the /16 networks say it's possibly down. After 240 seconds, these routes will get flushed from the routing table. So we're closing in on that time. I have executed the do debug IP routing command. So when these routes get flushed from the routing table, I should see something on screen. So I turned the camera off and I waited the length of the route flush timer. Otherwise, we would have been sitting here in silence. And look what happened. The route 150.101 0.0, the /16 route, got deleted from the routing table. So it says delete 150.101.0.0, and the RIP metric that it received to delete the route is a metric of 16. So router 1, and here there go network 20 and network 10 also getting deleted from the routing table with a hop count of 16. So why did this happen? Well, because router 1 sent router 201 a poisoned route with an infinite hop count and said, delete these routes from your routing table. Turn off debugging and look at our routing table again. And the /8 and /16 networks are gone. Now we see the correct mask for the networks, the 24 and the 29. So all is good. This is still the administrative distance. This number is still the hop count. So the first number is always the administrative distance. The second number is always the metric. In this case, the administrative distance is 120 and the hop count is 2. Now let's go to router 1. Last little tidbit. And say debug IP RIP. We're going to wait on some updates to go through. This was received in from router 2. I'm waiting for router 1 to send an update. Okay, so you should see that RIP version 2 sends its updates to the multicast address 224.0.0.9, not 255.255.255.255. So RIP version 2 updates are sent to 224.0.0.9. Now what happens if I shut down my Fast Ethernet link? Fast Ethernet 0/0 link. What happens if I shut that down? Well, let's see. I say shut down. Okay, nothing happened. Do use space all, no shut. Debug IP RIP. No. Give me a second here. So, what I'm going to do now is demonstrate route poisoning. I'm going to go to router 201 and say debug IP RIP and debug IP RIP events. And then I'm going to go check my routing table, make sure the 10 and the 20 networks are here, and they are here. And I'm going to shut down the Fast Ethernet link on router 1. So I'm going to shut down this link. Router 1 should send router 201 a poisoned update about the 10 and 20 networks. So let's see if that works. I say shut down on router 1, and on router 201, you immediately see that network 10 and 20 were advertised to router 201 and even the 150 network with a hop count of 16. which is a poisoned route, since 16 is an infinite hop count in RIP, for RIP. And with that note, this concludes the RIP portion of the lab. We're going to go ahead and remove RIP from each one of these routers by executing the command no router RIP. Next topic is EIGRP.